challenge. Which expression is not equivalent to x over y? Let's take a look at these. Pause for a second. Look at them. To yourself. To yourself. And I'll highlight the ones that aren't. That one's not. That one's not.
That one is.
That one's not. These aren't. 3 over 3 cancels. N cubed over n cubed cancels. So why aren't these? Because there's a plus sign right there. Just like, what is 4 plus 2 over 2? 3. 4 plus 2 is 6. 6 divided by 2 is 3. You can't cancel those 2's, right? So there's a plus sign. So let's erase that. And let's move on. Okay, so this is on that sheet that I passed out to you, but it's missing some operations, so just trying to fill them in. We're going to talk about what we know about basic fractions and try and apply that to rational expressions today. So today we're multiplying rational expressions. So somebody tell me, how would we multiply these two basic fractions? Straight across. Right? Multiply straight across. So when I do that, I get 1 times 5 over 2 times 6. Nothing factors at all here, so I'm just going to simplify. My next step. Simplify. So I would get 5 over 12. So let's use that same strategy for rational expression. I would multiply straight across. 2 times the quantity y plus 1 equals 5x times 7. Then I go ahead and simplify. I really don't want to just repeat that too. We'll just leave it like this. But I can. I've got a 5 and a 7 in the denominator, so that's 35x. Questions so far? Okay, let's look at this one. What's different about this one from this one? There's common factors in there. So we're going to do the same thing. We're going to multiply straight across, but as we're multiplying straight across, the numerator and the denominator, we're also going to factor and then simplify. So let's do that. 3 times 7, can't factor those, which is 3 times 7. Well, I can factor 14. How would I factor 14? 7 times 2, and how would I factor 12? 3 and 4. I'm paying close attention to what's going on in the numerator because I don't want to make extra work for myself. Instead of factoring 12 like 6 times 2, I look up here and go, oh, I'll factor it as 3 times 4. That way, these two cancel, and I'm left with, oh, something else cancels. 7 cancels. And I'm left with what?
1 over 8.
Let's use the same method over here with multiplying rational expressions. So I'm going to multiply straight across, keeping in mind my numerator and my denominator. I can't really factor anything up here, so it's just going to be n times n plus 5 all over n plus 5 times n plus 3 times n times n. Why did I break that n squared up? I factored it so that I can cancel an n in the numerator and an n in the denominator. That's about all I can do. Oh. Right. now I'm left with, what's the numerator? 1 over n times n plus 3, which is the same thing as n plus 3 times n. Doesn't really matter, right? Okay, so that way, we're going to finish that up throughout the week. Let's take your notes out and write these two problems down, please. Okay, so let's begin by multiplying straight across, but being mindful of factoring my numerator and my denominator. So as I multiply the numerator straight across, I'm going to express this as 5 times a. How should I write d2? We've got d squared times b, and 16? 8 times 2. You see that denominator? There's an 8 in it. And c cubed? C squared times c. All over 8 c squared. 3 times 5. Break up the a's and b. And it's back cancel. Times 5. Cancel a. Cancel of c. 8. Squared. I think that's it. And I'm left with 2b squared c. And usually put the variables in order. Of the offset, exactly. And 3a. But you'd still be right if you said 2b squared, right? It doesn't matter. Why doesn't it matter? What property is spoken into whichever order? Okay, let's do this one. Let's multiply straight across. 7 times x plus 1 times 2x plus 5 all over 2x plus 5 times x plus 1 times x minus 7. What do I need to get rid of? 2x plus 5. What else? X plus 10. I always like doing this. This is really easy.
Did you just check your letters?
So far, there's one thing we forgot to do though. What did we forget to do? Look at our instructions. These are excluded values, and you have to consider the excluded values from the original equation. So if we look at these excluded values, what can these variables not be? What can A not be? 0. What can B not be? 0. And what can C not be? 0. If each one of these variables were 0, it would screw everything up, right?
Yeah.
It would make it undefined. We can't have it undefined. These are a little bit different though. Would it matter if x was 0 here? No, it would just be 0 times 2 is 0 plus 5 is 5. But it would matter. I'm going to need some room for this. Let's go to this. Well, we can see this one pretty easily. What can x not be with that one? Negative 1. And x can't be what with this one? 7. But this one's a little harder to see. So what can I set this quantity up to see what x can't be? What did we do when we were trying to find where y was 0? Remember we used the quadratic equations when we were trying to find our zeros or our roots? What did we set equal to? 0. Equal it to 0. If I set up 2x plus 5 to 0, I can say, I don't want this to equal 0. Well, let's see what happens. Simplify, good. Then 2x can't equal negative 5 divided by 2. So x cannot equal what? Negative 5 half. Probably. And this is why. Let's take a look at that. Let's plug it back in. equals to what, -5 halves? Plus 5, what would happen? These cancel, and you get -5 plus 5 equals 0. We don't want it to equal 0, so x can't be -5 halves. That's pretty abstract. That's about as far as it gets. Not too bad, right? But there's a little bit of abstract thinking. You have to think of what number would I multiply 2 by and then add 5, and that would make 0. So I don't want it to do that. I don't want it to be 0. All right, let's keep going. A little more difficult. What am I going to have to do? What strategy am I going to take with this one? I'm going to have to factor out the multiply across, aren't I? I'll give you a second to write that column down and then factor it together. Okay, so what strategy do I take? Just like fractions that are multiplied, that are more simple, we're going to multiply straight across, right? So I have x minus 5. I'm going to break up that x squared. How am I going to break it up? X times x. My denominator is going to be x times, this whole thing is going to factor out. Let's factor it. X times x. What two numbers when I multiply I get -15, but when I add I get -2? 3 and 5. But one of them's got to be negative, right? So 3 times 5 is 15. So this one's got to be negative. 5 has to be negative because this value is negative. Right? So if you have a -5 and a +3, doesn't that make -2? If you can't do that yet, just use the x box. Okay? If that confuses you. So I think some of you are really starting to be able to do it. Cancel my x's, cancel my x minus 5, and I'm left with x over x plus 3. Let's take our excluded values. X cannot equal what? 0, -3, and +5. Right? That's the original values right here, right? If any one of those were any of these numbers, then this whole thing is not exist. Are you guys good? Good? Try this. It is funny. Okay, so let's do this one. I've got c plus 3. Back to this other one. It's a b and a b. 3 times 1 makes 3, but if I make them both negative, they make -4. All over 4 times b minus 3. C and D. 30. How would I break 30 up? And which one would be negative? 10. Cancel my b plus 3. Cancel my b minus 3. I think that's it, right? And I have b minus 1 over 4 times b minus 10. What can b not be? -3. 4 doesn't matter. It doesn't have a b next to it. 3, -3, and 10. Good job, guys. That's all I got.